Let's take a look at this problem. We got cosine theta is equal to secant theta. This is an example where we're going to use identities to put everything in terms of the same trig function. And we're again looking from 0 to 2 pi. Well, remember that secant is equal to 1 over cosine. Now we can't have a fraction in these, so I'll get rid of this fraction by multiplying everything by the LCM of all our denominators. We only have one denominator, so that is our LCM. So we're going to take cosine times cosine. And over here we'll take cosine times 1 over cosine. Cosine times cosine is cosine squared. And over on the right side, those cosine theta is going to cancel. It gives us 1. Now this is a square root property. The reason why is because we have cosine theta to the second power is equal to 1. And square root properties, whenever you have something squared equal to something else. So we'll drop our squared, and we'll put a plus or minus square root around the other side. So we get cosine theta is equal to plus or minus 1. And on my unit circle, here at 0, this is the point, 1 comma 0. And over here, at pi, this is the point, negative 1 comma 0. So if I go around the unit circle and I'm looking where cosine is equal to either a positive 1 or negative 1, well, cosine is the x part of our point, so our answer would be 0 and pi, maybe. We can change identities to other identities in order to work the problem, but we should always check our answer. So if I plug this back in my original problem, cosine is 0, cosine of 0 is 1. Now if I put 0 in for secant, secant is 1 over cosine, 1 over x. You could think it's r over x, but r doesn't really matter in these. So 1 over x. Well, x is 1, 1 over 1 is 1, so we get 1 is equal to 1. So that checks. Now if I put pi in, cosine of pi, cosine's our x part, that's equal to negative 1. And secant is 1 over x, so 1 over negative 1 gives us negative 1. So both of them check. So our answers are 0 and pi.